Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition.
Hello, everyone, and welcome to our Manufacturing Lunch and Learn. I'm Elizabeth Egler-Modick, Editorial Director of GIE Media's Manufacturing Group of Magazines, and I will be your moderator for today's session. This session looks at how automation and monitoring help optimize machine utilization. It's presented by Joseph Pizzoferrato, TNC Product Specialist with Heidenhain, and Joseph will be demonstrating how to make the digital shop floor a reality. Joseph is recognized as one of the go-to experts on TNC controls, and he's also involved in the digital manufacturing process, seeing this as the future of manufacturing that allows customers to stay competitive. So without further ado, we're going to go right to Joseph's presentation.
Thanks for the introduction, Elizabeth. And so my name is Joe Pizzoferrato, and what we're going to talk about today is how automation and monitoring helps optimize machine utilization. I am a TNC product specialist and an NC trainer at Heidenhain, and also do a lot of trainings for our TNC and ITNC controls. So why must we monitor or why must we automate different types of mold processes or machines? Well, for one, this leads to a higher throughput if we are able to use inspection cycles or if we are able to simulate programs or processes on a computer before we run it at the machine. That helps free up individual machines, and that also helps keep machines running by using inspection cycles for in-process inspection for critical features. A lot of times your critical features are going to be longer run times to complete some of those tasks. And use an inspection cycle at the machine, while it's not the end-all be-all, where you obviously would take it off and check it with a CMM, you can get some valuable feedback in terms of, do I need to take this part off the machine or not, and can I continue? We also use monitoring to help benchmark for future improvements, or what we call Kaizen events. Benchmarking is really the first step to seeing where you are and where you want to go. And a lot of times I put this in terms of, what is reality versus actuality. So a lot of times people think that they are a lot more higher efficiency than they are. And by taking an efficiency level only up a few percentage points, that can lead to higher profits in general for the company. Monitoring also gives you better and faster oversight. And what I mean by this is you have more data that's collected at your fingertips. Usually that data is put in terms of KPIs or key performance indicators. You are also can react a little bit quicker to different problems that's occurring. And it also leads to a reduction in the reaction time. So maybe you have some sort of an email or messenger system that is able to be sent to different personnel in the shop for quicker response. And one of the last things is just your ability to make quick updates, whether this is in terms of a tool update, whether it's in terms of a machine changeover, or whether this is in terms of a part dimension. You just have a better availability, better data at your fingertips due to the increased monitoring of the process or the machine tool or groups that you're monitoring. So for our agenda, some things we're going to talk about in regards to monitoring is going to be automatic touch probe cycles, using them to monitor the machining process and provide feedback to the control, and then using that feedback if we do need to recut. We're also going to talk about a process manager, which we call the batch process manager. This is a flexible management system that can be used to determine lights out manufacturing techniques and help overall efficiency ratings. Also, digital twins. We can use digital twins. We can leverage digital twins to simulate our machine, simulate our macroing, simulate a process, maybe tweak a process, and check that process on the machine, or on the digital twin rather, before we are actually running it on the machine. And then the last piece we're going to talk about is a monitoring software called State Monitor, and also another type of system we have called the remote desktop monitoring, which is a option on Heidenhain controls, and also some use cases in terms of the state monitor and where it would be a good place to use the system. So in general, in-process inspection cycles are typically going to be used for measuring features, perhaps giving you useful information in a data log. But a lot of a lot of other things come from inspection cycles. Some of our inspection cycles, data is stored in our Q parameters. So the parameters internal on the control. This data then can be macroed, calculated, maybe sent to a table file, or we can use that data in terms of interrogation or for logic statements. So if we work, or if we have scrap, or if the part is good, then we're going to continue on, or we're going to have to go back, make a modification, and make a mod to the tool and recut a feature. We also, like I said, we create in-process inspection reports. These reports nowadays are in terms of HTML files and also text files. And then, as I mentioned, we can also make modifications to the tool. So let's say we are milling a surface and we probe in the Z, then we're going to make a delta length shift to that tool. If we are milling a pocket or a boss or a circle and we're using the side of the tool, we can make offsets to the delta radius of the tool and recut that feature. And we would use a logic statement to check whether this feature is good or not. So we could either move on or come back and recut. And then we also use function 16, which is really just a custom error message you can create as an ASCII file. And we can also take that information and we could push that information back to the NC program. So data that's stored in there, maybe Q parameter data, we can take that data, put it back into the NC program for a recutting situation as well. That would be a little more of a complicated setup, but it's still quite possible. In terms of other in-process inspection cycles that you could use to keep your machine running, there are also new probe cycles for setup. They have some upsides and some downsides. So the upsides to these cycles would be they're highly advanced and you have endless capabilities. But the downsides are there's going to be a little more training involved. They're a little more difficult to master. And these would be our 1420, where we can probe a plane. So if you end up taking a part out and putting a part in, we would have to reprobe that part in 3 spots in order to align that flat surface to the spindle. That would be a 1420 cycle, and we can do this all automatically now inside these touch probe cycles. So very little intervention from the user at the control. We have 1410 to probe an edge, or 1411 to probe circles. And these edge and these probe 2 circles cycles not only can create our position for us, but they can also create our rotation, whether it's our spatial rotation or our basic rotation. So those are some pretty neat features that we have with these 1400 cycles. And like I said, there's a lot of other endless capabilities that these things can do. But for the purposes of this presentation, I'm just going to limit it to briefly talking about those cycles. Another form of perhaps automation you could call it would be some sort of a flexible manufacturing system, something where you can put programs in, run over the weekend, and have some sort of a seamless or a very minute interruption of pallets that run overnight. We have something called a batch process manager. This resides on the Heidenhain control, and we can feed it pallet programs. And these pallet programs consist of Heidenhain programs. And you can see that there's some columns in here. And the columns are checking for, do we have a work offset? Do we have the tool in the spin, or do we have the tool in the magazine? And also, do we have all the programs available for that particular pallet file to run? So this gives you a really good planning and a flexible system to be able to run over the weekend or even change the order of things. You can see there's pallets 1, 2, 3, and 4 in there. We can switch around those pallets if we turn our editor on, as long as the pallet that's in or the pallet that you're going to is not reached its countdown. In the upper right hand corner, we have a little countdown. So it's 12 minutes and 41 seconds. And when that reaches 0, then we cannot make an adjustment to the system. And of course, then when the next program runs or the next palette file runs, then you have additional time to change the next palette file that's going to be run. So this really gives you a way to run over the weekend and to plan which programs and which palettes you want to run if you're going to be running some sort of lights out manufacturing. Also, another way of automation would be using a digital twin. A digital twin is really a digital copy of an exact or an existing machine that you have in your shop. It is a very reliable in terms of creating good collision models for you. With a digital twin, what we do is we take all the machine components and all that information goes into the digital twin so that that is an exact replica of your machine, but on your digital workstation or on your computer. So what a digital twin allows you is simulation of whether you have a tool setter, whether you have some sort of a macro program, whether you have an NC program and you're trying to build everything together and check for perhaps collisions or check your macroing in combination with a main program. All this stuff can be used together inside of a digital twin for building the next program to be run at the machine without having to go to the machine and prove it out. All the proving can be done in the digital twin. And then at that point, then it's just dialing in the feeds and speeds. So a digital twin from Heidenhain, this is possible. What you need from us would be either would be a complete backup of the machine, whether you get that, whether we get that from you or we get that from your OEM, and then we would create quote for you. And then the other piece you would need is you would need either a dongle or you would need the Heidenhain keypad. One of those would be able to run the digital twin. So you have to have either the large Heidenhain keypad that we use for NC trainings, or you would need the dongle. And that dongle would plug into the USB port on your computer, and that would also allow you access to use the digital twin. A digital twin would be, we would consider this a level 3 digital twin. And um, simulators or downloads that you get off of our website, those downloads of those programming stations, I would consider to be just a level 1 digital twin, meaning it is not unlimited code and it is not an exact replica of your machine. It will not have you will not take your machine M codes. It will not have your cycle 300 so your cycle 300s it creates. It will not have your Bloom or your Renaissance laser cycles in there. Yeah, so those pieces of information will not have, whereas a digital twin will have that information for you. So you can simulate things more in a real-time environment on your computer. So another way of monitoring would be maybe remote viewing or remote looking at your computer that's internal in your shop, but maybe it's up in your desk on the second floor or at the other end of the shop, and you want to be able to view information across the building. Well, Heidenhain makes an option called the Remote Desktop Manager, and this would allow you to tap into your computer and you can then access anything that you have on your computer. So whether it's a technical drawing, whether it is a work instruction, or whether you want to get into your MES system or your planning system, or perhaps you want to get into your CAM system, this particular option would allow you the link up to your computer through the Heidenhain control and be able to do a quick check. Nowadays, we like to be a lot more modular, and we like to be able to grab things that we need where we typically would not have those capabilities. And this is one of those things where if we need to do a quick check in the cam, or we need to do a quick check of a drawing, we can access that through the remote desktop manager right at the control. So now when it comes to monitoring, why must we monitor our process, or why should we monitor our process? Um, well, a question that I would ask you is, how can we improve if we are not tracking? So if we're not manually tracking or tracking through a monitoring software, how do we really know what our level of efficiency in our current environment is? Um, what this does when you monitor and you use benchmarking, it turns your manufactured machine data into real-time insights. So different things that we can be used for benchmarking and tracking would be um, different KPIs, key performance indicators like availability, utilization, or OEE. And what this information can be used for is for creating a benchmark, and then from there determining where you lie in your current system, and then where do you want to go. If you don't have data at your fingertips, or you're not able to see what you truly are producing in terms of a metric, then you don't really know, you can't really gauge your process. So one question would be, how often are you utilizing your machine, or what is your uptime? So what is your utilization rate is really what that is, or how often is the machine in a green state? These things you can measure, and you can plot. You can benchmark these things over a course of maybe a week, a month, a quarter, and from there use that as your benchmark to determine, okay, where do we where do we think we want to go, and how are we going to get there, without really having data and looking at that data to find some sort of conclusions as to what's happening and where to move from. We really don't have good direction. Also, why must we monitor? Well, manual data is also really time consuming. So to write things down at a machine or on a clipboard takes time, and it can get lost. And it's really just better to have information that is inside of a server or inside of your monitoring software to be able to pull from when you need it. You can also evaluate program runtimes. So if you want to be able to see how long it took a particular job or a group of jobs to get done, that data is not going to lie to you. That's going to be good and accurate data that you can use. You can also visualize tool data. So perhaps your monitoring software can visualize the tool data, or visualize the data that's in the machine, and help you decide what tools you need for the next job, or what do we need to do to set up for the next group of jobs. We can also identify sensor malfunctions. So some monitoring softwares help us identify different sensors in the control. Perhaps for you have maybe erratic movements, or you have the machine comping kind of in a strange way. This information can be plotted, and if this information is plotted, we can get a better determination if there's really a machine problem, or really it's sort of a sensor malfunction problem. These are some of the pages that have software solutions go on our state monitor. The area on the left would be our overview of the total machines and our favorited machines. And we can see the number of machines. We have total machines 4, and our favorited machines are 2. And you can see the availability and utilization rate for both of those pie graphs. So really, we can take the data, we can manipulate that data to be able to um, present this as benchmarks for future improvements. Information on the right there would be the evaluations tab. We're looking at some key figures. here in terms of the machines, and that would again be the availability and the utilization rate. We're looking at a 3-day running time there, and that data as well can be broken down into bar graphs as well, rather than the pie graph that you see. And we can also export this data, which is a really useful feature. We can export this data as a CSV file or a comma separated value file. And then down below, I just picked. So we have different NC programs down below, and you can see the runtimes of those programs. And each of those on the x-axis would be the programs that run. So it's a total of 10 programs ran. And of those 10 programs, we can see different pieces that we're monitoring, where it's spindle, whether it's feed rate, whether it's rapids. And we can get some more metrics about each individual program down below. Another area of discussion would be, as far as the automation is concerned, would be automating of maintenance tasks. So maintenance tasks, a lot of times maintenance can be a challenging for shops. And what if you had a scheduler or some type of maintenance task scheduler that can help manage your shop, perhaps manage by quarterly or monthly, or maybe by machine hours, or maybe by machine runtime. These informations could be useful for helping you create more of a preventative maintenance system. And what also, if you're having reoccurring alarms or tasks, what are the reoccurring alarms and tasks that you could have? You can develop your own analysis based on these alarms and tasks. You can develop your own analysis of that particular machine, and plot what problems are occurring more frequently, and perhaps get some of those items addressed. When it comes to automating machine maintenance tasks, how can we avoid bringing around, paper clips or PM sheets? Well, if you could take all your information and you could digitally dump that information into a software, where you could have access to that via a tablet as a PDF format, this would also, I think, help to help clean things up a little bit in the shop. And what if this information was able to go what if this information was able to be funneled to a messenger, and different personnel in the shop were able to get that information, maybe on a 5 or a 10 minute increment? This would be helpful for a maintenance staff. So another part of the state monitor that we have would be the maintenance manager. The maintenance manager allows us to create the maintenance tasks. These maintenance tasks, we can also assign faults to them. We can assign a fault or a report that you see with the orange triangle over here. We can create a ticket. So if we end up getting a fault or a malfunction, we can also create a ticket, or perhaps a different scenario that is unrelated to a PM. Our maintenance manager can also manage their maintenance documentation. And like I said, we can also put that information in terms of a PDF format. And over here on the right, you can see that we have some pending, some completed tasks. We have a total of 5. You can see task number 1 has been completed. And so we can see in there, we've got monthly maintenance, yearly maintenance, daily maintenance, and outstanding maintenance. So really, you can build a comprehensive maintenance plan and maintenance scheduler for individual machines. And this can all be managed based on you, and based on how often you want to be performing these tasks. Another topic of concern on the monitoring side would be, well, why more data? Why do we have to have so much of this data? Well, when let's have couple of cases here. When you have a machine that is running outside of its range, or you are not hitting tolerances on your parts, um, perhaps you've checked the touch probe, you've checked the machine, you don't seem to see any problems with the machine, but the machine is behaving erratic, or it is outside of its normal realm of scope. Or case number 2, um, what if you need to know when your machine is warmed up? When are you at operating temperature? What if you could monitor your machine base or your machine envelope for operating temperatures? When are things stable? So this data can be useful for us if we were able to monitor different signals about a machine's components to get a better feel if there's a problem or when the machine is ready for production. So a solution we have for this would be a signals terminal we have inside of the state monitor. The signals terminal allows us to connect up to 5 signals, and these are of many different data types. And what we can do is we can also set upper and lower limits on them, and messages can be then sent to appropriate personnel, perhaps in the maintenance department, or perhaps to maybe one of the guys running the machines who has a maybe a better feel of the machine, and if there's if it's an abnormal process. So this is more information that can be used for you for again determining if the machine is behaving in a quote unquote like erratic or jumping situation. Perhaps you're not hitting your tolerances. This is an area that should be looked at. Numbers say more than words. You get an additional 3,168 hours out of your spindle if the productive machining time is increased by 15% when operating 5 machines in 2 shifts. Another number that I like is with 10 minutes of undetected machine downtime per shift means in a 2 shift operation over 264 days at an hourly rate of $150 costs the company $66,000 each year. So these are big numbers, and with some monitoring and some improvement on that monitoring, you can really help increase your ROI on your machine tools that you spend your money on, and also help bring in more jobs into the shop. So this is one of the use cases, and this would be a case for transparency. So the first thing people usually want to ask is, well, how productive is my machine? Well, that's where we create the benchmark, and you move from that benchmark. So what our monitoring software is able to do is generate either a daily view or a 3-day view, or you can customize that based on the evaluations area if you want to create more of a monthly view or a bi-weekly view of how productive is your machines. And so you can see here we have 4 different machines, and we have it color coded by green, light green, yellow, red, gray, and dark gray. And some of these color codings can now be customizable as well in the software. And what we're viewing here is the availability and utilization rate to the right of each machine. And so that graph shows you from 0 to about 14 hours, so 14 hours of runtime, how productive is the machine during that runtime. And you see the breakdown based on the color coding, the percentages, and also the breakdown on availability and utilization rate. So seeing transparency in the machines that are in the shop there. Another use case would be identifying non-productive times. So one question people ask is, why is my machine not as productive as I would expect it to be? Well, if you have a lot of maybe not productive states, maybe you have a lot of yellow states, um, our software is able to allow users to customize those machine statuses. In the settings tab, we can create different sub statuses. And so down below here, I have a few that I've created, and I've also tabulated them in a bar graph where I've used the evaluations tab of State Manager to create a bar graph based on just the yellow status range. So one reason why the machine is not productive or is kind of in a waiting situation is perhaps you're waiting on quality control for an existing job that came off the machine. Perhaps you also have a problem with the programming problem. So perhaps you are in the middle of proving something out on an NC level. Maybe the machine is sitting due to a break in the schedule, or perhaps maybe the machine is being reprogrammed with the CAM software. So those are just some examples. What we can do is, based on the statuses the machine has. If that isn't good enough, we are able to go in and make some customizations through our status section of the software. Another use case would be the reducing unplanned machine downtime. So how can we reduce this unplanned machine downtime? So the problem is my machine stops working during an unmanned shift and nobody sees it. We have a very useful messenger feature, and this messenger feature allows us to send out a lot of different information to different personnel on the shop floor, from maintenance personnel to programmers to operators to production supervisors, information that perhaps is pertinent to them, and we can also send it out within a certain time frame, and we can also send out status information about the machine as well. So when a status changes, a person will be notified. When a machine goes back up or goes down or goes into an e-stop, a particular individual could be notified. So a really good use case for using a messenger would be you have a lights out manufacturing system, or perhaps you have machines running over the weekend and a machine stops unintendedly, perhaps on a Saturday or a Sunday. At that point, if you are not connected to that machine in any way, or you cannot see the control and don't know, then the machine sits. So the solution to that would be having some sort of messenger or email system being able to be sent to an appropriate personnel so that action could be taken. We also can do data transmission, and we can send data either to an MES or an ERP system. So a use case for this would be, what if we want to transmit our collected machine data or job data, and we want to send that information to either an MES or an ERP system, perhaps for quoting or logging. We have a external reporting database. Over here on the right, you can see all the different databases that the state monitor uses, from machine to alarm to messenger to state history. That information is all stored in databases. And what the state monitor allows us to do is send that databases out to a Microsoft SQL server. And through the connection to an SQL server, any computer or any MES or ERP system can then pull from that SQL server. So this can really help perhaps the IT department, or like I said, the people that are quoting the jobs, to get more information at their fingertips and to not have to do double work. If the information is already stored in State Monitor and you have a way data, then you don't need another system to be able to map that data. Because all the data is in terms of SQL tables, so you would need to do a lot of SQL mapping to send that data out to an MES or ERP system. I also mentioned digital maintenance manuals. So if we want to take logs or PMs from paper, and we want to digitally send them into a software, we can do that. We can send them into our maintenance terminal. So how can I plan and schedule maintenance task from the maintenance manual? Well, we can create tasks, we can create steps, we can have due dates based on time, machine hours, or for maybe semi-annually or quarterly. And we can also be notified when to take action on that. And then we can also take those PMs and that information and send that into the maintenance scheduler as a PDF for the individuals that are going to be performing that work. So this again reduces the amount of paper that you're going to have. You have the documentation, you have it at your fingertips, perhaps on an iPad or at your computer, and it's just more of a digital flow of information, quicker, more efficient, and cleaner. I also want to mention we have a complete log of malfunctions and alarm messages. So a use case for this would be maybe your machine is failing and you have a lot of unexpected malfunctions, or you have a lot of reoccurring alarms. What's the best way for your company or your machine operator to notify maintenance department if you're having a problem? Well, you could even take that a step further, and you really wouldn't need a machine operator if a maintenance department or a maintenance supervisor or manager was viewing this information on a weekly or a biweekly basis. He can track this information himself. He can see what alarms are occurring more frequently and where perhaps he needs to take action based on that. So, to have some concluding remarks about automation and monitoring, um, I think one of the big things, one of the takeaways about monitoring is it provides you with transparency. It provides you with um, pertinent information that you can use to set your benchmark, and from there you can then create continuous improvement or kaizen events through the use of that data. And if that data is not sufficient, then providing the software with more data or sub data to then get to the root cause of what the problem is. KPIs can be tracked. This is terrific for metrics. So for your equipment, your availability, your utilization, different metrics, how long a machine is up, how long is a machine productive, how long is a machine down. These things we can all measure. These are KPIs that can be measured and tracked and provide you with good metrics going forward as benchmarks. And about machine utilization, I also want to mention from an automation standpoint, automatic touch probe cycles and flexible manufacturing systems such as a pallet management system. The ability to use a pallet management system in combination with probing cycles for not only setup but also interrogation is terrific ways to increase your machine utilization in a mold shop environment. This also minimizes downtime due to your messenger and your email notification as well. So if you have a messenger and email notification system set up, that also can increase your uptime. It allows you to be a little more quicker, give you more quicker reaction time to the situations occurring. For more information on monitoring or tips and tricks on NC programming, you could visit Clartex-portal at Heidenhain.com. In there, in the software section, you can find a lot of information pertaining to state monitor. You can also find a lot of good webinars regarding programming or perhaps regarding touch probe inspection cycles. You can find a lot of good information on the Clartex-portal website. So a lot of good information on there, free information available if you go searching for it. And then if you have further questions, you can contact us at tncapplications@heidenhain.com. If you have any questions about the touch probe cycles that we discussed about or the monitoring software, different modules in general. So I want to thank you all for your time. And again, my name is Joe Pizzaferrato. This was hopefully educational, and hopefully you learn a little bit about different things you can do in your shop regarding automation and monitoring. And I want to thank you for your time.
Wow, that was a wonderful presentation from Joseph. He is unable to be with us today to answer questions, but Michael Ammon has joined us and will be able to address some of the questions that have come in during the presentation. We are going to head on to the first question, and can you connect to other controls? Okay, he is going to type out the answers to me, so I will read them. Yes, we can. Common protocols are MT Connect, OPC-UA, and Modbus. Heidenhain now has a Focus, FOCAS, interface, which makes it possible to connect numerous FANUC controls without any additional solutions. And another question came in asking if the touch probe cycles are an option. 99% of them are not. They come as a package with the NCSW that is on the control. And we've got time for one more question here. Can your touch probe cycles probe freeform surfaces and or create vector data? Yes. Cycle 444 and cycle 4 can interrogate freeform surfaces. Cycle 444 takes into account the radius of the touch probe, whereas cycle 4 does not. Cycle 4 is used quite frequently with metrology software. Well, that looks like those are all the questions that have come in today. Thank you, everyone. Have a wonderful day.
You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.